Hey everybody! Today we're going to be looking at graphing linear inequalities. This is section 932, and we're going to be looking at graphing linear inequalities and how nonlinear inequalities is different from what we've been doing with linear inequalities, those straight lines, y equals mx plus b. Now today we're going to really start by looking at what we're going to do with a parabola, because those are the most common family of functions that we're going to be encountering here in Algebra 1. And so we're going to talk about what to do with these. We're going to not only talk about how to go from like a graph to an equation, but also how to go from an equation into graph form. So there's two different approaches we're going to take as we go through these two different concepts, these two different changes from our algebra web. For a parabola, we can approach the equation creation. This is again if we're given, so we're going to start, by looking at the graphs and how we go from a graph into an equation. Now we can approach this in two different methods or two different forms. And it kind of just depends on the graph that we've been given. You have this glue in as well, so make sure you have it all nice and glued in before proceeding with this video. Otherwise, you're not going to be able to do most of it. So here we go. We can either approach going from a graph to an equation from vertex form, or we can use factored form. We can't use standard form because standard form only gives us the c value, which is great if we need the y-intercept. But we also need the a and the b value as well, so we can't start by using standard form. In this case, I would look at my graph that I've been given in order to figure out if I can start with vertex form or if I'm going to start with factored form. By looking at this graph, I see that it actually has not given me the coordinate of the vertex. Therefore, I actually can't start with vertex form because obviously I would need the vertex to be able to use it. In this case, I'm going to start with factored form, aka my x-intercepts. So what I'm going to start by doing first is identifying the x-intercepts on my paper. I'm going to have to work backwards from what the x-intercepts are into the factored form. Sorry, that was like a dramatic pause. So I'm going to start from using my x-intercepts and work backwards to put it into the factored form of the equation. So here we go. It looks like my first x-intercept is located at x equals positive 1. And then my second x-intercept is located at positive 6. So I have x equals 1 and 6 as my two x-intercepts. Knowing that I need to work backwards using the ZPP, I would therefore put my values into the factored form, but I'm going to make them negative because I know that x minus 1 is the only way to use the zero product property to end up with a positive 1 x-intercept. And same over here with the positive 6 as the final solution. I have to plug it in into the equation as x minus 6. Again, thinking back to that x minus h component of factored form, or x minus p and x minus q. Now, here's the new kind of thing, and we have talked about this before, but we're going to talk about it more in depth today. We have to keep track of the a value of our parabola. So outside of the factored form, we're also going to include the value of a. We're not entirely sure what a is, nor can we really tell just by simply looking at the graph. So we need to include the a value on the outside. What I'm going to do is I'm going to pretend for a little bit that this isn't even an inequality, that it's just an equation. And I'm going to put y equals. This will help me, and I could go ahead and do the dashed versus solid and the above or below, but what I want to figure out first is what is the a value of my parabola. So first what I need to do is I need to choose another coordinate somewhere on my parabola. For this, I think I'm going to choose the coordinate 0, 6. I cannot choose the x-intercepts that I already chose. Every time you choose an x-intercept, you'll end up with an a value multiplying times 0, and that will not work. So that would end up with y equals, it's just going to be a hot mess. So what we need to do is choose a non-x-intercept. Well, that's cool. I chose my y-intercept instead. I'm going to plug in 0, 6. I'm going to plug in 0 for the x value, and 6 for the y value into this equation right up here. So now I have 6 equals a parentheses 0 minus 1 parentheses 0 minus 6. I'm going to simplify this. I still have that a on the outside. Negative 1 times negative 6 is going to give me a positive 6 times a equals 6. My goal is to get that a all by itself, so I'm going to divide by 6 on both sides. Anything divided by itself is 1, and so I know that I have an a value of 1 for this problem. That's great. Now what I know is that I don't actually have an a value. Well, I have an a value of 1, which means when I go ahead and create my equation again. Whoops, I did not mean to write that 6. I'm sorry, that a. I actually have an a value of 1, which means that I could just simply write this equation as y equals 1 parentheses x minus 1 x minus 6. But now I have to do my other components because I do realize that this is an inequality. So I'm going to first ask myself, is it a solid or dashed parabola? In this case, it's dashed, which is always going to mean there is no equal sign involved in the equation inequality component of it. The second question I ask is it shaded in above or below? In this case, what's cool about parabolas is that it's very easy to tell if it's above on the inside or below on the outside. In this case, it's shaded below, which means that we're going to have y is less than the rest of the parabola, aka the x values. So when I go to put my equation into final form, I'm going to write this as y, let's see, no equal sign with a less than sign. So y is less than parentheses x minus 1 parentheses x minus 6. Now let's say the problem tells me that they want it in standard form. Well, no problem. I can rewrite this using my generic rectangle, of course, multiplying my x minus 1 value times my x minus 6 value. Using that generic rectangle, I figure out that my standard form of this equation will end up being x squared minus 7x plus 6. And either one of these would be totally great final answers. Again, it kind of just depends on what the problem is asking for. Factored form, standard form. I could even go a step further and put it into vertex form by completing the square with these three, with this trinomial over here on the right-hand side. It'd be a little tricky with a -7, but I could do that. But we haven't been asked to do that in that problem, so we're just not.